Excellent. Well, without further ado, I'd like to hand it off to our last presenter, James. We are so glad you were able to make it. Yep. James was supposed to kind of kick off the day, but, well,
Wrap up.
airlines and travel and all that. Here, I'll give you this one.
Okay, cool. Hey everybody, thanks for having me. Yep, you know how it is with travel and airlines and all that stuff, but it's good. I've heard some good jokes here already today. Kubernetes in production, that's great. We're gonna have more of that. That's about the level where my comedy is gonna hit. So, really excited to be here with y'all today. We're gonna be talking about some chaos, security, DevOps, and really, I've kind of baited you all. We want to talk about DevSecOps. So, hopefully that'll be interesting. I just moved over recently to a company called Verica. Verica does some chaos engineering stuff along with the security pieces, so we're really excited about that. I have some courses in the LinkedIn Learning Catalog or lynda.com if you're familiar with those, where I have access to them. So if you like this 30, 45 minutes, you got 9 hours that you could just sit and listen to my voice, put you to sleep, I guess. So I'm also down in Austin with several of my friends down there. We help run the DevOps Days Austin, Serverless Days Austin, and we're working on DevSecOps Days in Austin this fall. So if you're interested in that, be happy to have some barbecue with you or hang out or whatever you want to do. And we're working on this book. We're still trying to make progress on it, the DevSecOps Handbook, and it's just writing a book has just been a little bit of a difficult thing. Well, this is one of my favorite O'Reilly titles, and this has really helped me in my career. And so if you're like me and you're like, okay, I kind of just half listen to stuff and mostly I'm just on Twitter during conferences, you can send an email to my email address, wickett@verica.io, and I have my autoresponder set up, and it'll automatically send you the slides. So like you don't even have to think from here on out, you can just get it. And if the headers is stuff like, best talk I ever saw, so funny, that thing about Kubernetes in production, hilarious. So anyways, okay, like I said, that's my joke. So I work at Verica. We do continuous verification, and we're doing chaos engineering. We're taking the principles from chaos engineering, and we're trying to take a proactive and measured way to prevent availability and security type incidents. And so we're really excited. But if you go to verica.io, we're just a logo. We're just getting started. We're very light on what we're doing right now. Okay, so DevSecOps. Security has a nice, lovely place in the middle. And you may be thinking, why? Why DevSecOps? And I think we could go to our friend, Jack Handy, and go to the DevSecOps Deep Thoughts. Maybe in order to understand DevSecOps, we have to look at the word itself. Basically, it's made up of 3 separate words. De, Viseco, and Ps. What do these words mean? It's a mystery, and that's why so is DevSecOps. Okay, yeah, that's funny, I guess. I promised low expectations, right? So that's I'm trying to deliver that. Okay. First, we got to understand DevOps and how we got here. So, I think, hey, let's do a quick tour of that, right? So that'll be special. Okay, we had the cloud and then all of our data. It got really big, and we're like, yeah, this is great. And the new OSI model. This is my new favorite thing about the whole thing, because that old one I was always confused the layers, and that this is much easier to memorize. And really we started turning into this approach where we're able to separate our waste and value. And so and we're we see the kind of delivering on that promise over kind of each era of as we're consuming services here. And so as we move further down our journey, we started this idea of thinking like, oh, hey, we get ops for free with serverless, right? Oh, we get security for free. Well, we all know that's like not really true, but we saw DevOps grow hand in hand with the cloud. And this is kind of the philosophy. If you believe this, you're kind of taking the approach that DevOps is this inevitable thing that we couldn't escape, and it just kind of happened and was forced upon us. And Tom Limoncelli also has a very similar view to this. He says DevOps is the inevitable result of needing to do efficient operations in a distributed computing and cloud environment. When you're doing tens, even hundreds of servers, you can have like one person kind of ratio for that. When you're doing thousands, like you need a new way to operate in that model. I always think about it too. I think it's this point where we're able to break these groups who didn't know what they were actually building, developers and operations, join them together around a common problem, and that's that epistemological breakthrough. And I know someone in the audience is like, is he going to actually say the word epistemological? Well, there we go. All right. But the big problem is like we have this divide where like labor was not set up to work together. So in traditional organizations where we saw this kind of in the last 10, 15 years where we'd have 10 developers to every one operations person. You had this whole throw it over the wall mentality, this separation, this siloization. And Damon Edwards over at Rundeck, he says this that I think is really great. He says DevOps is not a technological problem, but DevOps is a business problem. And I find that is like that really resonates with me as well, and I really like that. And you can also take the view of like we're just seeing Agile's continued journey across the business, across the organization, and continuing to be successful across that to bring everybody else into the process. And so I kind of like this this approach. This other definition or another way to think about it is DevOps is the application of the Agile methodology to system administration. And so, all right, maybe we buy all that and we think, okay, DevOps, that's good. We believe in it, and I think that's kind of battle has already been done. But then, okay, why are we doing this with DevSecOps? Why is it separate? Why does security need kind of this other approach to it as we're kind of growing? And I asked myself the same question. I was sort of a latecomer to DevSecOps, like as far as using it and thinking that we needed to make a separate way for security to kind of take part in it. And I was like, when will we stop? And other people have said the same thing. And security finds itself in the same position, though. And I think this is where we kind of build some empathy muscles and we think about where security sits in many organizations. We see like 100 developers to one operations, or to 10 operations people to like one security person. And does that resonate with you? Have you seen that in organizations, right? Some people, I've presented this before, and some people with this slide, and they're like, oh yeah, it's more like 200 to 1, right? Or 100 to half or something, right? Which I guess the math on both of those is equal. So, but the whole premise is like we're creating these silos, these natural silos where these groups are no longer able to work together because just the inequity that's going on there. And I feel like security really struggled to provide value in most organizations. And here's like security voices, the security prophets themselves kind of saying what's the problem statement here is. There's this guy, Steve Belovin, he wrote the book in the late 90s on the firewall. That was like the book, the Bible on firewalls. And I guess a couple years back, he released this book called Thinking Security. And in it, he has this quote that really resonated with me when I read it. So I'd like to read it to y'all. It says, companies are spending a great deal on security, but we read of massive computer-related attacks. So clearly something is wrong. The root of the problem is twofold. We're protecting the wrong things, and we're hurting productivity in the process. Does that resonate with you? Right? It's like we're not, like the breaches haven't gotten any better. Like they continue to actually get worse. And now we're finding out like we're actually slowing stuff down. The security team is the people they like to avoid. And then there's this other quote that I put in almost every presentation I give because this is whenever I first started realizing that security had a different path or needed to come up with a different way. And if you started, I like to study the history of something to understand like how we got to a point where we are. And so if we look at this, The Tangled Web, it's a book on securing modern web applications, but the first chapter is dedicated to security and security engineering and how it kind of went throughout the decades. And, through crypto in the 60s and 70s and kind of move forward. But in the 90s, there's this quote that sort of that I got interested in, and I was like, what happened? Where did we make a big error? He says, doing security by risk assessment introduces a dangerous fallacy. That you could have that structured inadequacy is almost as good as adequacy, and that underfunded security effort plus risk management are just about as good as properly funded security work. And as an engineer, like that really bothered me. Like, why would we just want to like buy an insurance policy for something or start doing actuarial type work on something whenever we could like really go and do engineering and fix the problem? And I think security had the heritage of that, but there was a big shift in the 90s and onward for this type of approach. We still see it today. The SANS survey did a DevSecOps survey, and they say, while engineering teams are busy deploying all these leading-edge technologies, security teams are still focused on fighting yesterday's battles. They find that like 95% of security professionals spend their time protecting legacy applications. And this leaves us to this interesting statement of like, well, we can't ever, and we see this across all tech, so not just security, but the burden can only be transferred to other people. And we saw that with kind of our movement of the division between waste and value as we move to serverless. And that same thing is true for security. Security burden isn't created or destroyed, it's merely transferred to somebody else. And so I think that is a core part of the problem. Another part of the problem is that many security teams are working with this worldview where they want to inhibit change. Does anybody know security people? Or I guess I should ask, like, is anybody here like kind of pro security or like kind of consider themselves mostly security? Got a couple, yeah, okay. But like, how many security people do you see as like helping things go faster, right? But how many people see security as making things go slower, right? That's the approach that we see. A lot of heads are nodding there, and now we're seeing all this new technology and this increased focus on organizations on software delivery. It's kind of where I decided, hey, this DevSecOps thing like really is important. Like, it is something that is helping bring security into the fold. I've talked to many security people who've said, yeah, I thought the DevOps people, that was like separate and like we weren't part of that, but like now, like I feel part of it under this story. So I started thinking about like, well, what can we do to like help prepare someone be successful as a DevSecOps, as a person who is part of this new breed of security, and helping them realize, hey, it's not a tool, it's not a pipeline just with security slapped into it. You don't buy it on an expo floor as much as RSA would like you to believe that you can. But I like to think of it as this inclusive person that's participating of the movement of security into DevOps. And so this is why security is even so nicely just like right in the middle there, right? It's taking part of the whole flow of DevOps. And out of this, I've built this thing called the DevSecOps framework, and I'm really curious if this is good or bad. It's like pretty new, or if you like it, or if you don't, or you have any recommendations for me, I would love to hear that. You can send me an email or hit me up on Twitter. But I have this framework called Measure, and so Measure breaks down to this: being maker-driven, doing experimentation, automating, being safety-aware, unrestrained sharing, ruggedizing, and empathy first. We're going to try to take like a look into each of these pieces real quick, and sort of get some ideas of like how security and kind of fits in this kind of overall DevSecOps story. All right, so we'll start with Measure here. So first is maker-driven. So first, I think we realize that software engineers they need to specialize the recognition in security that, hey, we're software engineers and we just happen to like be specialists in the security discipline. And I think that's really helpful for us. And this is among security people, this is not a popular point of view all the time, depending on which camp you sit in. But I think security needs to be part of the story of being able to write code. We had a really excellent discussion here just a second ago on like how to help sysadmins bridge that gap into development. I think that same thing is also true for security. And so I'm actually concerned in the security side, like, why is this a hot take that like people don't like this? And I got like a lot of hate mail or hate tweets, I don't know, whatever it is, on this point recently. And but I feel like there's a lot of resources available today for people to learn how to code, right? These are two of my favorites, and they've served me well over the years. And that's that. Again, I promise low bar here on this. But I feel like we need security to like adopt the maker mindset, and security's already doing that. Like they're already using DSLs. Like I think there's this gap where it's like it happened in operations whenever they made that jump from just doing sysadmining to like more of a DevOps approach, where oh yeah, like I do write some scripts. Oh I do know like how to this is like a decade ago, right? But it's like I know how to Apache config like 50 other people in the entire country, right? It's like I actually am a really expert in this topic. I'm already kind of using a DSL, and we see this with we can always pick on the WAF, right? Typing dots and slashes until things work. That's always a rule for success. But this is an approach like getting security to write code and have this be part of the story. This is not something that we're just doing in theory, but we're seeing people at large organizations like Shannon Leitz over at Intuit, Aaron Reinhardt whenever he was over at United Healthcare Group. They were said, hey, it wasn't code or you're fired, but kind of, right? It was like learn how to be a part of the pipeline, be part of the delivery process, be part of the story of security taking part of that. Even if you consider yourself like a red team or pen tester, like put some of that into the pipeline, right? Even if you're on the compliance side, put some of that into the pipeline. And this is important because it helps security people have empathy, get familiarity with tools, able to move stuff into the pipeline. I know even whenever I was first picking up some of my first serverless applications, I like started out like, oh, I'm going to do this in a very secure way, you know, like lock it all down and then just open up that. And, you know, 30 minutes of that, you're like star, you know, all the privileges. Like, I don't have time to mess with all this. But it's that's an empathy building skill that security needs to realize that, like, whenever you're building something, you want to just get something done, and that's a gap that we often have where security is like, no, we would want it. You want to secure it all first. So it's like, well, I don't even have anything. Like, well, there's nothing to secure. Like, I got to get something built out the door, right? I think there's also this misconception that like bugs should be treated different than like security defects or like vulnerabilities, or, you know, we have all these like ways to classify systems and CVs and CWEs, and there's a whole mess of that on the security side. But I think what I try to challenge people is like a bug is a, oh, well, it's supposed to say bug on my slide over here. It says it, but it's cut off. But mystery, right? What it is. But, you know, yeah, it's a bug, right? And when we look at it, I started getting interested in this topic, and I looked back through all the defect density studies I could find, you know, all the way from the 80s and onward. And you can find it different studies range, different papers say different things, but it's always like half to like 10, depending on like the framework or the language or whatever it is, and old and modern, new, whatever. But the point is, like, per 1,000 lines of code, like, you're always going to find defects, and defects are never going to be zero. They may like occur in certain parts of the code base or more frequently, but you're never going to get humans writing error-free code. And I think a lot of times there's this hesitation on the security side, and we see this a lot in the space where we've abstracted several layers and we're just like writing some lambdas or whatever. It's like, oh, hey, but my applications, it's just a few lines of code, right? A couple hundred lines of code. Well, I stole this example from Sneak with reference here, but 222 lines of code for a serverless Java application, 5 direct dependencies, 54 total dependencies. And so how many lines of code do you think this thing actually had? How many? 15,000, okay? It got any more? 15,000 going once, going twice? No, okay. Yeah. 460,000 lines of code is what you're actually looking at, right? So we're inheriting all these things. So you look at all the dependency management, software build materials, all that sort of stuff. Like, all that's got to be part of the story, because this is your life now. But sometimes it's just a little subtext down here, like that little descriptor just makes me laugh. So, anyways, I work from home, don't get to talk to people a lot. All right, so here's a good question that was in the DevSecOps survey this year. It says, how well does your organization control which open source and third-party components, libraries, and binaries that are used in development? So if you are a DevOps elite practice, or you have no DevOps practice, it's the blue to the red. You can see that even if you are like the DevOps elite, they kind of have some other questions earlier in the survey to categorize that. You're still not like 100%. You're not even close, right? So we're still struggling with like how we deal with dependencies and how we bake all this sort of stuff in. Here's another hot take or another view here is like, you can't just, so I think with all this, you can't really train developers to write secure code. I think security's always had this approach, well, we'll just put them through their once a year PCI training and like, they're good, right? You know, it's like that 1 hour was really well spent, and they will never write another software bug ever, right? But what do developers actually do to stop writing bugs, right? They don't get everybody into a conference room and have them sign off on the sheet that says that they've accepted the training. They do like test-driven development, behavior-driven development, ATTD. They try to make meaningful comments or commits. We were just talking earlier about like refactoring your code base. They think of like code smells, like, oh, like this doesn't feel weird. Making sure we do pairing on certain parts, like, oh, this is the auth system, like let's pair on that, right? Or we're sucking in user input here, let's figure that out. Adding instrumentation where it matters. So I think this is, and I really like this book, and I have several slides out of here. So if you're kind of working on kind of bridging the gap, this is one of those books I would put forth as a good idea for you. But in the Agile Application Security book, they say the goal should be to come up with a set of automated tests that probe and check security configurations and runtime system behavior for security features that will execute every time the system is built and every time is deployed. And then you start connecting, when you do that, you start connecting security with quality. And we start seeing some other results from the DevSecOps survey, where one in four developers believe that security is synonymous with delivering quality. I don't know if we would have said that, 5, 10, 15 years ago, but I think like that message is starting to come out, and this is going to grow even further. So what does it mean being maker-driven? It means seeing security as part of engineering, viewing quality as a way to bring security in, using code and not necessarily vendors to solve all your problems. There's definitely place for putting in vendors at the right spots in the pipeline, but kind of using that approach first. All right, so let's go through experimenting and also learning from our experimentation. So experimenting needs to be measured, repeatable, results that are based on your needs, which I think is really helpful. Shannon Leitz and I gave this talk at DevOps Enterprise Summit last year, and we take the what you think of. This is a part of this is just one slide of a larger talk, but Shannon set up this great experiment where it's like, well, we think these blue ones going diagonally here, that's the OWASP top 10, and this is what we think like the distribution of like traffic would be against some of our honeypots and this experiment cluster that they set up. But when we figured it out, we started breaking it down by adversary type, and you could see that like the scanners kind of hung out over there, paid noise kind of just like spent a lot of time doing this kind of junk over here. Researchers and advanced adversaries kind of all had different approaches for how that they were attacking the site. And so once you start classifying the who, then like the what they're doing becomes really interesting. And this sort of research really, this sort of experimentation really leads to ways that you can figure out ways. You'd want to put like a different blocking mechanism or different monitoring mechanism in place for these different classes of folks here. And you can detect what matters here. So depending on your system and depending on your application, but account takeovers, what part of the site's getting attacked more, looking for abuse and misuse cases. One of my friends, Zane Lackey, over at Signal Sciences, he says, we can't cede home field advantage. I think a lot of times in security we would say, oh, there is no such thing as an unhackable system. Well, one thing to realize is like you're the actually only people who know how your system is built, how it is deployed, how it runs, how your customers use it. I mean, you have a lot of data around your system. Yeah, we can't make it like impenetrable, but like you have home field advantage, so don't lose that against the attackers. And part of this just necessitates knowing steady state, which a lot of people don't know, and like you'd be surprised. When I was used to work at Signal Sciences, we would always go in and be like, hey, do you know where you're getting attacked, and where people are having success? Just real basic questions, and very often people can't answer even that level. I won't ask us to raise our hands here, so you don't have to, call out, your company or whatever. But so I think there's some good resources. Shannon Leitz is over at DevSecOps on Twitter. Definitely follow her. And then if you want to watch that talk where we kind of talk about the whole process of experimenting and how we laid out the experiment and then what we found out of it, and then kind of some of the organizational changes, I think that's pretty interesting and might be helpful. Okay, the automation of things. Like we all love automation, right? Like I think whenever operations first kind of came into the DevOps world, automation was a big key for us. And I think for security, that's going to be the same as well. In 2016, Shannon delivered this talk at DevOps Days Austin and broke the build up into these stages, and it said, what are the security questions we need to be asking at this point? And I thought that was really helpful. And then we start seeing in the DevSecOps survey here in 2019, the blue are the elite folks, DevOps elite, and across your entire pipeline, where do you implement your security tooling? And so you can see the blue definitely outperforms the red in this, whereas the previous one not as much. But in this one, it's definitely a game changer. I would say that. So automation provides feedback. You do this in pre-commit, at build, at deploy, at runtime. And we start seeing even older technologies or technologies that have been around in the security world for many years, like a web application firewall, open source governance, static application analysis, dynamic application analysis. Really, you can make an argument that out of these 5 things, the only thing that's kind of novel is container and application security, which even then you could make an argument that's just a rework of some of these other things. But you see folks that have been doing DevOps and have been doing kind of more like the elite practices according to the survey, they're outpacing their non-DevOps practices considerably, even with kind of this older style of technology. So one thing I think is helpful as we think about continuous delivery and where we put security inside of this. I like Jez Humble and David Farley's quote where they say continuous delivery is just really how little you can deploy at a time. And whenever we were at Signal Sciences, I was on the engineering team there, and I helped us build out our entire delivery pipeline. And we really focused on that whole total cycle time bit. That's the amount of time it takes from you commit a piece of code into your source control into like the time it takes to running in production. And so we would literally like gather the whole team together. You know, it's a small company, so we could do that and say, all right, like this build step's taken 2 minutes. That's way too long. Who can fix it, right? And like, how do we make this faster? How do we branch it? But we really focused as a team, like we own this build process, and like once it gets out of like 5 to 10 minutes range, like alarm bells go off, and we gather all the troops together and say like, we can't do that, because when you start doing builds that take like over 10 minutes, then people start like batching their commits, and then you kind of lose your granularity, and it kind of breaks down. And we had a lot of success with this. Yeah, sure, we're a startup, we're a small team, but we did over 15,000 deploys in a little over 3 years. And we started putting put security in the pipeline there. We had software composition analysis, language linters. You can use things like GitHound, Gauntlet, which is a product that I help out with, or open source tool I help out with, adding monitoring and telemetry inside there. And once we do this, like the Agile Application Security book says like, yeah, hey, once you build your pipeline in this manner and you've kind of instrumented it with all this security stuff, now you can like just sort of have these, you can get rid of the cab and all that other stuff, and you can sort of have this pipeline that allows you to push stuff out frequently without doing these like heavy change review meetings. So you juxtapose this to the quote like at the very beginning with like with Steve Beloven saying like the twofold problem. Well, like when you start doing this, like you at least you may or may not fix the breach problem, but you definitely fix the speed problem. And so like I think that's a really helpful thing to think about. A couple resources for this if you're doing automation. I have 2 classes inside of the LinkedIn Learning catalog on this. One is building a secure continuous delivery pipeline. So it walks you from soup to nuts, from code commit all the way to running in production and all the different pieces. And then I have another one where it's more of a deep dive with that automated security testing tool Gauntlet, and shows you how to like script out all these tools. So if you're interested in that. All right, S is one that I think is going to be really big, but is not yet. But I think it's something that security is starting to resonate with, and that is safety in complex systems, system safety. So I'll try to tell these kind of quick. But okay, there's I don't know. You might have noticed, like I'm a little taller than the average person, and usually it's great. I'm a big hit in grocery stores to get the stuff off the top shelf, and my mother-in-law loves me when I come to visit because I can reach stuff for her. But a real problem is doorways. And you wouldn't think that. You'd be like, oh yeah, but average door is 6'8". I'm 6'6". Put on some tennis shoes. Get excited. You could it gets really close. And so this is not the door that was the infringing one, because this is more of a modern, taller door here. But you see that little device in the upper left-hand thing? Anybody know what that is, right? That's like the badge scanners, and it's got the door lock. And anyways, well, my daughter goes to she goes to a school that has like older buildings, and I got a zoom in shot. So this thing, and I was taking her to school. We were running late, and I just totally biffed this thing. And it was so much so that I was like, okay, am I having a concussion? I don't know if I am or not, right? And I was wearing a hat, and we were in a rush, and so and this is like this is a very simple system. Like a guy walks into stationary object kind of scenario, and I'm embarrassed to say this, but I feel it kind of helps think about our situation. Well, when we think about safety systems and we start trying to apply some of that logic, we see you'll hear the 5 whys. 5 whys is a really good way to get to problem to diagnose a problem in a system, but it often works in simple systems but fails in complex systems. It can even struggle in into the guy walks into a stationary object, because it's you can take a lot of questions on, or you can go a lot of different ways on answering this problem. Well, okay, why do we even have to have locks on the door in the first place? Oh, well, it's a school, and there's society issues. school shootings and other stuff like that, right? So okay, we want kids safe, like that's good. And then but and then why was it so much lower than average? I actually started researching. Like I was like gonna email the school like there's new ones that like mount up like higher, right? But maybe they bought it at a point whenever they needed to purchase that to have security for the school. And I was wearing a hat. Why? Because I was like, oh man, I'm running late. I'm just gonna run out the door, take her to school. And why is that? I went to bed late. And then why? Oh, I was living life in a hurry. I mean, you could kind of like trail on whys like all over the place on this. I go through that door every single day, like to drop her off to school. It's like, how did I like somehow forget that was there? Just that one moment, right? So all that's fine, but like we abstract complexity in systems. And so when we think about human beings, like we are complex systems, but then when you isolate it to just as like, person walks in a stationary object, you kind of separate yourself from that. Societal issues, psychological, cognitive load. And that's what we do. Like, and we do this with software too. Like software deals with complexity just with abstracting things away. And that's really one of the ways we solve a lot of engineering problems, for good or for ill, right? One thing I'd like to leave you with is this is in all the safety stuff is that root cause is a myth. And so when we think of that we can have some sort of root cause and point to an individual, we sort of forget the whole organizational decisions that got us there. We are kind of that implements sort of a blame culture inside of your systems. And this is really important for security because the joke in security is like you become a CISO because it's like you just want to get fired in 2 years, right? It's like you just kind of warm the chair until like some big breach happens, and then they got somebody to point the figure at, and all CISOs know to like negotiate like some sort of golden umbrella policy or parachute policy or whatever they call it these days, right? But it also puts the focus on the event over the overall situation that had the event occur. And also we need to remember that complex systems aren't linear. And so as I started thinking through this and I've been becoming more interested in the safety side of things, I've been reading this book, Drift into Failure. And this quote from Sidney Decker's book says, "Drifting into failure is a gradual incremental decline into disaster driven by environmental pressure, unruly technology, and social processes that normalize growing risk. No organization is exempt from drifting into failure." So this is the This is the second story, and this is the kind of the Boeing 737 Max stuff. Are you guys following this or interested in this? I know kind of read pieces of it. Punchline is the very last bullet here. It's automation software. Like how are they fixing the planes? Right? They're deploying a patch. So that should cause any of us that are like doing software delivery, like we're going to be in for a world of hurt, I think, of legislation and other stuff as this stuff unfolds. But the systems, as the events happened, like all this stuff happened in like a matter of minutes, like near takeoff. The software is fighting the pilots silently. And the whole time, the system is telling them that they are driving a 737 flying. I'm not a pilot, sorry, but they're operating a 737 just like every other single one they've ever operated their entire system. So they're missing that critical their entire career. So they're missing that critical kind of feedback loop there. Let's see here. So I think whenever I started reading all this and started understanding, like, okay, we're in an interesting spot here. Like high-speed decision-making sounds really familiar. It sounded familiar from the operations side. It sounds familiar from the security side. And it is proof here, like we're seeing the software eating the world. We're seeing all this kind of come to fruition. And, we see this growth, and another quote from Decker's book is, "The growth of complexity in society has got ahead of how understanding of how complex systems work and how they fail." So I took this, this is a easy getting started diagram of serverless, right? Like that's complicated. Like microservices, all microservices are like this, right? But that's complicated for an operations or security or developer, whatever you are, to keep this mental model in your head, right? The old school 3-tier, web app or whatever, like sure, like had some problems, but like I could figure it out, right? This, like, not a clue. Right, and so we need a new model for how we're going to do detecting and how we're thinking about safety in these systems, especially as it's separated out. My friend Matt Stein sort of summarizes this, and software was probably a mistake. I don't know why that makes me laugh every time I see it. But he's a dev evangelist over at Pivotal. He's written a lot of books on software, so I think that's why it's even more funny to me. But operation and security still has that burden to rationalize all those system models, and so this is a problem. And Adrian Kokov says this. He says failures are a systems problem because we haven't added enough safety margin. So I think somewhere in this story, there is a security and safety, and there's something that's going to meet here. And I think this area is still kind of unfolding because we're seeing that like normal systems have failure. Almost everybody in like the DevSecOps survey reports, like last year was 1 in 3, this year it's 1 in 4, like got breached, suspected breach. We're seeing this continue to happen, so we need other ways to approach our problem instead of kind of this like let's fire the CISO and just move on type of thing. So security fits in by adding safety margin, trying to do telemetry and instrumentation, adopting the same idea of blameless retrospectives. And really, I think there's more to explore in this area, and I'm kind of excited about this. So here's some. If any of this was interesting to you, there's a great YouTube series here by Sidney Decker. If you're like, oh, I don't know if I want to commit to like a 300-page book, but like I'm happy to do that. Also, J. Paul Reed's coverage on Boeing is really interesting and really great, and he actually has flown planes, or I think he's a pilot. And then Richard Cook's paper, if you haven't read this, it's on how complex systems fail. I would totally recommend. This is a great place to start. He's a medical doctor and started writing about like how our bodies fail and break down over time. And when you first read it, you'll be like, oh, he's not a software engineer? Like, that's weird. So, all right. So I know we're kind of running low on time here, so I'll try to fly through the next few here. But the next one is unrestrained sharing. Security is not the best at like being sharers. In fact, like you could ask many security people, they want to keep the walls separate between all the groups, or at least like old school, I would say, would do that. But Patrick Dubois said this early in the days of DevOps getting founded and whenever it first started, right after he coined the word. He said, culture is the most important aspect to DevOps succeeding in the enterprise, and I still think that is true. And so this gets back to our definition earlier. DevSecOps is the extension of the DevOps culture for the inclusion of security. And that's what we're seeing. And Rich Smith, when he was at Etsy, he said a security team who embraces openness about what it does and why helps spread understanding. And we see that sharing just overall kind of affects the culture. So, but this sort of goes against, rubs security against the wrong way. Sometimes this is against their standard operating procedure. It feels uncomfortable. It's like it's breaking down these silos that they're used to being there and these barriers. But I like to think of these 4 keys as having mutual understanding, having shared language, shared views, collaborative tooling, and we see this in practice. Like. We see kind of some gaps, really, too. Like if you look at the top challenges that your application security processes face, these are what some people reported. Okay, we find about problems too late in the process. Okay, we kind of probably already knew that. But a lot of developers report that like they don't even know what's expected of them. And it's like we're not even clear, like 20%. Like say, like we have no idea what security wants. And so I think that's problematic, right? So security shares through making the invisible as visible, adding security observability, kind of thinking through like where to add inside of APIs, the webhooks, any sort of dev tooling that can fit. And it's finding what's below the surface, below the iceberg here. And not just what we see as like our common piece. Like we talked a little about this in experimenting, like what are the common OWASP attacks? Like maybe that's what we deal with, but really like account takeovers and stuff where we're really facing. And so instrumenting that. I like how Jason Chan over at Netflix says this. He says, security needs to be takes a paved road approach. So if you're using kind of the normal way to do software delivery, it just sort of comes along for free. And that includes the auditors. And we have this project called dearauditor.org. And if you have any auditors in your life, feel free to share this with them. We like people that love it or people that hate it. We're interested either way. But this is a love letter from DevOps to auditors. It's at dearauditor.org. And in it, we also provide a DevOps risk control matrix that helps kind of map the two worlds together. And we're still working on this. This is kind of a work in progress, but we're totally interested. And it's on GitHub. We take pull requests, take issues and tickets and stuff like that. Any other resources on this I'd recommend are like the Phoenix Project, Agile Application Security, or that Dear Auditor site. All right, let's move on to R. So ruggedization. It's running everywhere. Okay, so think about the software bill of materials. Know what you know what you have. It says know what you have up there. Okay, knowing what you have inside of your system. This is also favoring short-lived systems where you think of cattle, not pets, and that kind of framework. Sunil Yu has this DIE framework that he's trying to prove out if like systems are just naturally more secure or provably more secure if they just have these three aspects of distributed, immutable, and ephemeral. So there's some work being done on that process. I also think that like ruggedization and the way that we're thinking of hardening and putting resilience in our systems, I think for security it has two paths for success over the next 18 months. I think deception, where you're like putting honeypots or tar pits or anything like that to kind of like isolate attackers by type. I think that's going to be a place that's growing. And then I think the chaos space is growing, so which is one of the reasons why I kind of moved over to Verica, because I was excited about it. So these are some of the deception pieces. And here's a quote from Adrian Cockcroft again, but just saying we're moving from disaster recovery to chaos engineering to resiliency. So there's a path and there's a journey that we're following here. And if you're interested in chaos engineering, I think there is one of my favorite resources to point people to is Michael Nygaard's book, Release It. In it, he because I think there's always this approach that, well, okay, Netflix can turn off systems because like people just restart the stream. Like I work at a real company, like we can't just do that, right? And I think that's an approach. But Nygaard in his book says, hey, yeah, well, it's empirical. It's an empirical approach, and we don't use models to understand what the system should do. We run experiments to learn what it does, and it's all about learning and taking kind of this approach. And he makes it very doable for like enterprises or people that aren't Netflix and can't handle that type of experimentation. And so I totally recommend it, but it has to be the second edition. He only added those bits in the second edition of his book. All right, and let's see. So doing some experiments that span engineering and security. Make sure that you have some valuable learning out of it. Some of the tools that kind of fit in this are Chaos Slinger, Chap, Chaos Monkey. Here's some good resources if you're interested in. The top two are chaos related. The bottom two are deception related. And kind of this one, Herb Todd's talk or at LastCon he gave is like really, really good. If you're new to the deception space or you think the security folks would benefit from that, it's pretty cool. All right, and the last one is one that I saved for last. I debated should it go first. I don't know, but having empathy-based teams. And so we'll go back to the well. When I think of all the arguments the CISO and I have had, I realize how silly most of them were. And it makes me wonder why he wanted to argue over such stupid things. I think I'll go ask him. But there's a problem where in our industry we think of those stupid developers. Those are phrases and words kind of emitted out of security's mouth. And then I've had developers tell me it's like, hey, you just want a machine powered off and unplugged. Like I was so separate from the business that I didn't even care, right? And I was like, no, I like paychecks, so we got to keep those turned on, right? But security or developers are not really the enemy, but we've kind of created this problem where they are. And so having empathy for them. And one of the things that they reported in the DevSecOps survey is that year over year, developers always believe that security is important, but they just feel like they don't have the time or resources to spend on it. So I think one of the things I would leave you with is like, don't be a blocker, be an enabler, help bring other people along for the journey, help bring security in for the journey, help bring developers into the security story as well. Okay, so that's Measure DevSecOps. Thanks for kind of having me, kind of going through this progression here. If you felt like any of it was good or bad or have an idea for like a different way to spell this thing, I'd be totally interested. You can hit me up. If you're interested in the book, we are taking stories of anybody that's going through like DevSecOps transitions, successes, failures. You can email book@devsecops.org, and we'd love to talk to you about that. And again, if you want the slides or you have any content to reach out, you can hit me at wickett@verica.io, and that's it. Thanks.
Excellent, thank you. All right, time for some questions. And do know that we will have a video of this, and we will get his slides posted on newopsdays.org. So I know there's a lot of cool stuff there, and it's easier to click the link when you have the slides.
Yeah, it is, yeah.
All right, any questions? Going once. Going twice.
Yeah.
Sold. Yeah.
Yeah, either one's, yeah. Okay. I know there's traffic. That's of concern. I know.
I always try to think of at least one question if nobody asks a question. So, security. Have you guys ever thought of the model of embedding a security engineer in each team the same way that it was talked about earlier, to have an ops person in each team, have a security engineer in each team?
Yeah, so like how do you, I think the question is really like how do you structure teams for this? Security is in a bit of a rougher situation than operations was. Like there's just not enough headcount to go around for that. I see shared models seem to work pretty effectively, where you kind of get kind of a a group and they engage with the security team, and they'll kind of do some embedded pieces of it. Other models I've seen work, Matt Tessaro's done a bit of work on this whenever he was over at Pearson, building out an AppSec pipeline, and they kind of spend a lot of time building that out, and then they kind of help the teams get started with that. I think in many ways, like the advice I always give security people are try to figure out ways how to put that automation in the pipeline, be a resource. And I had this guy, a friend of mine, call me who's like the head of security at a large enterprise, and he said, "Hey, DevOps, like, this is like about 6 months ago. It's like DevOps, yeah, like a lot of people are talking about that now. Like, what am I going to do about it?" And I was like, "Oh yeah, you got a problem on your hands, because he wanted me to like give him some recipe, I think, like to how to let it just disappear, And my advice to him was figure out a way to never say no again. Because they're going to win the battle. Like we're already seeing it. I mean, I know some organizations, DevOps kind of blows up, but whenever organizations that kind of get the drug of like being able to release, on demand, or just push deploys out at will, and unlocking all that hidden value, and kind of just, I mean, we know all the benefits that we've seen on that. But once they get a taste of that, they're not going to want to stop that. And so if you're going to be a blocker on security, you need to figure out how to like add into the pipeline, add testing in there, put the instrumentation in there, kind of take that cross section of like all the way from development and design all the way to running to production, and then say like, okay, what are the tools and process and things that we can put in place, and then just hustle as much as you can to get that going. I think an embedded if you have the resources, totally, like an embedded security thing would be good. But most organizations I talk to, they're like, yeah, we got like 1 or 2 or 0, right? And so then it's now finding tools or software, and people that can, like, maybe they're security friendly. I know some security. This is the last other tactic that I've heard people do pretty successfully. They'll run like a red teaming or a hackathon or a security capture the flag type event. You find anybody who's like who did really well in that, and they kind of become like your security deputies or ambassadors. They get the special like hacker t-shirt or hoodie or whatever. But it sort of builds a culture around where like security is a cool thing, and I've seen a lot of companies do that where they kind of make this approach, and then now they have a someone on their side inside of those teams, right? Because I mean, you're really there at the point of like security's way outnumbered, so it's like beg, borrow, and steal from any place you can, and that's what you end up having to do that. So, all right,
excellent.
Cool.
Anything else?
Hey, thanks for having me, y'all. It was great.
All right,
Yeah.
Thank you, James.